Happy morning, students. Today we will see the continuation of triangles exercise 6.5. Fifth problem. ABC is an isosceles triangle with AC is equal to BC. If AB square is equal to 2AC square, prove that ABC is a right triangle. Now let us draw a triangle ABC, isosceles triangle with AC is equal to BC length. We want to prove that this triangle ABC is a right angled isosceles triangle. Now coming to the solution, he has given triangle ABC which is an isosceles triangle. So AC is equal to BC. It is given in the problem, calling this as equation 1. Also, it is given in the problem, AB square is equal to 2AC square. I am going to split up this 2AC squared as AC squared plus AC squared. So I got AB squared is equal to AC squared plus AC squared, calling this as equation 2. Now I am going to substitute equation 1 in equation 2. So I am going to replace this AC as BC. So I will get AB square is equal to AC square plus BC square. So by converse of a Pythagoras theorem, which states that if the square of the first side is equivalent to the sum of the squares of other two sides, then the angle formed which is opposite to the first side will be 90 degree. So from the figure, so we have taken the first side square as AB square. So where the angle which is opposite to AB will be C. So the C, by the converse of Pythagoras theorem, we got 90 degree. So we framed ABC as a right angle triangle. So I am writing angle C is equal to 90 degree by converse of Pythagoras theorem. Hence triangle ABC is a right angled isosceles. ABC is an equilateral triangle of side 2A. Find each of its altitudes. He has given the triangle ABC where we are drawing an altitude AD, and he has given that the triangle has a side of length 2A. So I want to find out the altitude length AD. Since triangle ABC is an equilateral triangle where the altitude touches the base at its midpoint for the equilateral triangle. So also it is given that the side length of the triangle will be 2A. So where the base, since D is the midpoint, I can say BD is equal to A and CD length is equivalent to A. Now we need to find out the length of AD. So I am going to take the triangle ADB, and using Pythagoras theorem I will be finding the length of AD. Now coming to the solution, in right triangle ADB we know that AD is an altitude. So the angle formed at D will be 90 degree. That is ADB angle will be 90 degree. So I am going to use the Pythagoras theorem where the side opposite to angle D will be AB, which is called as the hypotenuse. So I am writing the hypotenuse square is equal to the sum of the other two side squares. So which is equal to AB square is equal to AD square plus BD square. So in the triangle we found that BD length as A, since D is the midpoint of BC. So I am substituting my BD square as A square, and we know that AB is a side of an equilateral triangle which is given as 2A. So I am substituting AB square as 2A the whole square. So I got 2A the whole square is equal to AD square plus A square. So when I expand, I will get 4A squared, and bringing this plus A squared to the other side, I will get minus A square, which is equal to AD square. So 4A squared minus A squared will be 3A squared, which is equal to AD square. So AD is equal to square root of 3A, which will be the length of the altitude. Seventh problem. Prove that the sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonals. Now let us draw a rhombus ABCD whose diagonals are AC and BD. We want to prove that the sum of the squares of the sides of the rhombus is equivalent to the sum of the squares of its diagonals. That is, we want to prove AB square plus BC square plus CD square plus DA square is equal to the sum of the squares of its diagonals, AC squared plus BD squared. So let us come to the proof. To the solution, we know that the diagonals of a rhombus bisect each other at right angles. So we get angle AOB is equal to angle BOC is equal to angle COD is equal to angle DOA is equal to 90 degree. So in the figure where AOB, BOC, COD and DOA all form 90 degree when two diagonals intersect. Also, we know that OA will be equivalent to half of AC because the diagonals of a rhombus bisect each other. Coming to the figure, so my OA, I can write this OA as half of AC since the diagonals bisect each other. Similarly, my OB, I am writing it as half of BD. So now I am going to take the triangle AOB, which is right angled at O. So I am going to take right angle triangle AOB. I am going to use the Pythagoras theorem. So in right triangle AOB, we have AB will be the hypotenuse square. So AB square. In right triangle AOB, where we will get AB as a hypotenuse. So by Pythagoras theorem, the hypotenuse square is equal to the sum of the other two sides square. So you will be getting AB square is equal to OA square plus OB square. But we have taken OA is equal to half of AC, OB as half of BD since the diagonals bisect each other. So I am going to substitute OA as half of AC and OB as half of BD. So we get AB square is equal to half of AC the whole square plus half of BD the whole square. Now I am expanding. I will get 1 by 4 AC square plus 1 by 4 BD square. Taking 1 by 4 commonly outside, I will get AC square plus BD square. Taking this 4 to the other side, I will get 4 AB square is equal to AC square plus BD square, calling this as equation 1. Similarly, I am going to take a triangle BOC, COD and DOA. So for all these three triangles, I am going to use the Pythagoras property. Similarly, in triangle BOC, I will get BC square is equal to 1 by 4 of AC square plus BD square. Bringing this 4 to the other side, I will get 4 BC square is equal to AC square plus BD square, calling this as equation 2. Now for triangle COD, we will get 4 CD square is equal to AC square plus BD square, following in the similar way. And similarly in triangle DOA, we will get 4 DA square is equal to AC square plus BD square, calling this as equation 4. So we got totally 4 equations. Adding all the 4 equations, so we get 4AB square plus 4BC square plus 4CD square plus 4DA square is equal to 4 times of AC square plus BC square. So which is equal to 4 AC square plus 4 BD square, taking 4 outside. So here I am taking 4 outside. So I will be getting 4 into AB square plus BC square plus CD square plus DA square is equal to 4 into AC square plus BD square. Cancelling 4 on both sides, I will be getting the sum of the squares of the sides of a rhombus will be equivalent to the sum of the squares of its diagonals. Eighth problem. In the given figure, O is a point in the interior of triangle ABC. OD is perpendicular to BC. OE is perpendicular to AC and OF is perpendicular to AB. Show that OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equal to AF square plus BD square plus CE square. Second subdivision, AF square plus BD square plus CE square is equal to AE square plus CD square plus BF square. He has given the figure triangle ABC, where O is the interior point of the triangle ABC and OD is drawn perpendicular to BC, OE is drawn perpendicular to AC, OF is drawn perpendicular to AB. Join OA, OB, OC. Now in right triangle OAF, my AFO is 90 degree. So my hypotenuse will be OB. So by using Pythagoras Theorem, OA square is equal to OF square plus AF square. Similarly in triangle OBD, my OB is the hypotenuse. So OB square is equal to OD square plus BD square. Similarly in triangle OEC, my OC square will be equivalent to OE square plus AC square. So we are going to write this in our proof. Now coming to the proof, considering the triangle AFO, as we said, we have OA squared is equal to OF square plus AF square, that is hypotenuse square is equal to OF square plus AF square. Now I am going to take this OF square to the other side. I will be getting OA square minus of OF square is equal to AF square. So in my proving part, we need to prove that AF squared plus BD squared plus CE square. So for that case, I am going to take AF on one side and OF to the other side, so that I can have AF squared is equal to OA square minus OF square, calling this as equation 1. Now coming to the next triangle OBD, where you have OB square, that is hypotenuse square is equal to BD square plus OD square. Similarly, I need BD square, so I am taking OD square to the other side. I will be getting BD square is equal to OB square minus OD square, calling this as equation 2. The third triangle COE, we have OC is the hypotenuse. So by Pythagoras theorem, OC square is equal to CE square plus OE square. So I want to have a CE squared on one side. So I am going to take OE square to the other side, so that I will be having CE square is equal to OC square minus of OE square. So calling this equation 3. Now equation 1, equation 2, equation 3 have been got by using the Pythagoras theorem. Now we are going to add equation 1, 2 and 3. We get the left hand side AF square plus CD square plus CE square, and the right hand side which is equal to OA square minus OF square plus OB square minus OD square plus OC square minus OE square. So rearranging the right hand side, I will get OA square plus OB square plus OC square minus OD square minus OE square minus OF squared. So hence I proved the first subdivision. Now, the second proof is AF squared plus BD square plus CE square, which is equal to AE square plus CD square plus BF square. So we are going to take now left hand side of the equation, so that I can prove that the left hand side is equivalent to the right hand side. So we need to prove the second result by using the proof of the first one. So we got from the first AF squared plus BD squared plus CE squared is equal to OA square plus OB square plus OC square minus OD squared minus OE squared minus OF squared. So I am going to make a small rearrangement here, where I am joining minus OE squared with OA squared minus OF squared with OB squared and minus OD squared with OC squared. So I am writing it as OA minus OE squared plus OB minus OF squared plus OC squared minus OD squared. We will see in the triangle. So I have rearranged such that my OA squared is joining with minus OE squared. So OA squared minus OE squared, which will be equivalent to the AE squared. Similarly, OB square minus OF square. So I am taking the triangle OBF, OB square minus OF squared, I will be getting BF squared. Similarly, OC squared minus OD squared, taking this triangle ODC, OC squared minus OD squared will be getting CD squared. Going to substitute the values here, so that I will be getting here OA square minus CE square is equal to AE square, OC square minus OD square is equal to CD square, OB square minus of OF square is equal to BF square. Hence we got AF square plus BD square plus CE square, which is equal to AE square plus CD square plus BF square. Hence, ninth problem, a ladder 10 meter long reaches a window 8 meter above the ground. Find the distance of the foot of the ladder from the base of the wall. We are going to draw the figure for the given statement. So where we are taking the ladder as AC. So this ladder reaches the window at A, where A is at the point where the window is 8 meter above the ground level. We want to find out the distance of the foot of the ladder from the base of the wall. We want to find the base BC. So we are going to use the Pythagoras theorem in the right angle triangle ABC, where AC is the hypotenuse. So coming here, by using Pythagoras theorem, AC square is equal to AB square plus BC square. We know that AB will be the distance of 8 meter, and BC, we want to find out the length of the base BC, and AC will be the length of ladder, so that is 10 meter. So squaring it, so we get 8 square plus BC square, which is equal to 10 square. So I will get 64 plus BC square is equal to 100. So bringing the 64 to the other side, I will be getting BC square is equal to 100 minus of 64, which is equal to 36. BC is equal to square root of 36, which is equal to 6 meter. So where BC is nothing but the distance of the foot of the ladder from the base of the wall.